Alright, in this video, we are going to repeat what we talked about during classroom time about the awesome sinusoidal application. So blah blah blah, make sure activate your eagle eye. Do you see my A, B, C, D? Alright, so given a function talking about the hours of the daylight, and given the function is a sine function, so step 1, remember what will be my parent's function about sine function. So the sine function is starting from my midpoint, go all the way to my maximum, then to my minimum, and back to my midpoint. So this will be the curve of my sine function. But as you can see that this function is more complicated to collecting the data about the hours of the daylight. So now you see my A value indicate my amplitude, and I see my B value. Now again, B value controls the period, but not the period. We need to solve that, okay? And we got the midline, which means the principal axis. And now you also see that there is a parenthesis, something to do with the x. The x controls the horizontal movement, so you know that it's to the left or to the right. My curve going to move to the left or to the right. So x minus, that tells me I'm going to move my curve to the right direction, 81, okay? So, eagle eye. When we solve problem, pick up the keyword. The shortest day tells me I'm looking for my minimum, and the longest day is my maximum. So, activate knowing my principal axis, my midline. I can say that how high can I go? So that will be plus my amplitude, and how low I can go minus my amplitude. Good. All right. When we talk about the time, conversion about the time, we like to use the 24-hour system. So after noon, so when you say 1, 2, 3, 4, 5 all the way to 12 o'clock, but 1 o'clock in the afternoon, we just plus 12. So 1 p.m. equal to 12 plus 1, which will be 13. And that's how we got 11 p.m. That tells me will be 11 plus 12. That will be a 23. So now we're going to backward to see the sun sets at the time, then what time will be the sunrise? So we're going to calculate the backward. So the way I do it is knowing the keyword, the longest day. So I know my maximum. Whole number tells me is the entire whole number for the hours. So I need to take care of the decimal to convert the decimal hours to a minute. So times 60. Once I got the minutes, we talk about it in classroom. So simple calculation, round it up to 50. So that's easy for me to do. So I'm going to counting the time backwards. So 23 minus 20, that tells me the time will be 3 a.m. And I still need to go backward to see what time 15 minutes ago. So that gives me is a 2:10 a.m. Okay. C, we talk about the period controls by B. So activate the eagle eye. You know that the B is given to us by my awesome eagle eye, and because that is a sine function, we know that number is very small, so we're going to use the pi. So the 2 pi is my parent's function, sine function, the period. So 2 pi divided B value, we know that. Okay. In class, we talk about that. 365. That remind me of the number of the days in a year. So that's how the application comes in. So this will be the application. How long takes the Earth to rotate around the sun? Okay. So come to the C value. C value tells me to the left or to the right. So this moment it is rounded up to 81. So this tells me it's the 81 days into the year, which means that marks the first day of the spring. Hello. And this is the beautiful about using the real life application to link with the knowledge of the math. All right, part E. Simple one, as you can see, the shortest day tells me will be my minimum. So now make sure they ask for the setting time, the sunset. So knowing from part A, the minimum is 4 hours, and the whole number 4 hours, and I'm going to convert the decimal to a minute. And once I convert the minute, and then we say that I'm going to start the time 9 o'clock plus 4 as the whole number is 13, and I'm going to convert the minute plus all the minutes together. That gives me the final answer. Good? Okay. Example 2, just a classic way for math people to collect the data. So remember what we say. When there is a picture, the answer is in the picture. Do not overthink. The two things I want to point out will be when we have the information X and Y, okay, you're going to activate your eagle eye. Do you see some coordinates indicate my minimum and maximum? So I do see. I see my minimum, I see my maximum, and you may say that, Zone, what will be the purpose about doing that? So when you look at this one, it just tells you to plug the point into your graph. So every time when you plug a point, you do know that the midline comes to help us to see the amplitude, verify that. And when we look at the particular period, it's always back to the picture, okay? So the way I do it, just simply plot the point back to the graph and then nicely curve that. After the calculation, you will see that I can just apply the math and do it. So when there is a picture, the answer is in the picture. And that's all I want to say. Good? And that's all. Thanks.